Rebecca Heisman for our final 2025-26 Virtually There Speaker Series presentation before our summer hiatus. Rebecca Heisman is an award-winning science writer whose work focuses on ornithology, wildlife conservation, and the ways scientists uncover the hidden stories of the natural world. Based in Walla Walla, Washington, I love saying that, what a great literary name. She has written for numerous respected publications and organizations, including Audubon, Scientific America, Living Bird, Bird Conservation, and High K magazine. Before becoming a full-time science writer, she worked with the American Ornithological Society, where she helped communicate groundbreaking bird research to broad audiences. Rebecca is perhaps best known as the author of her engaging and well-researched book, Flight Paths: How a Passionate and Quirky Group of Pioneering Scientists Solved the Mystery of Bird Migration, a widely praised book that explores the remarkable history of how researchers learned where birds go, how they get there, and the innovative technologies that made those discoveries possible. Through adept storytelling, she reveals not only the wonders of bird migration, but also the creativity, persistence, and curiosity that drive scientific discovery. Rebecca has a gift for making complex science accessible, entertaining, and most of all, deeply human. Please join me in welcoming Rebecca Heisman here to captivate us with wild stories from the history of bird migration research. Rebecca, you can share your screen and begin whenever you are ready. And remember, everyone, please leave your questions in the chat for Rebecca and we'll try to get to all of them at the end of her presentation.
Thank you so much. That was an amazing introduction. I think I need to hire you to be my hype man or something. That was awesome. All right. Well, I am so happy to be here this evening. Thank you for having me. The book came out in 2023, so I'm really honored that I'm still getting invited to give talks about it. This is fantastic. As he mentioned, I am in Walla Walla, Washington, so I'm kind of in the opposite corner of the country from you all, but this is fun. All right, so yeah, I'm here tonight primarily because I am the author of this book that, as I mentioned, came out about, gosh, over 3 years ago now, about how we know what we know about bird migration. So I spent a couple years of my life immersed in this topic. I read more scientific papers than I could possibly count. I talked to dozens of scientists, including a lot of ornithologists, but also a surprising number of computer scientists and geochemists and surprising folks like that. I got to join a couple of those ornithologists in the field to tag along while they were carrying out their research. And I just feel really privileged to get to tell the stories of the scientists who are profiled in this book. I still feel like they are the real experts, and I am just here trying to bring the amazing things that they're doing to a wider audience. And that's a really fun job to have because there are so many good stories to tell about bird migration. So here are just a few of the amazing migrators whose stories appear in my book. On the left-hand side of the screen there, that's a bar-tailed godwit. Some of you might be familiar with this. These are the birds that make the longest known non-stop migratory flight. So in the fall, they take off from Alaska and they fly all the way across the Pacific Ocean to like the vicinity of New Zealand without stopping at all, without setting down. In the middle, that's a bar-headed goose. These birds make what is probably the highest altitude migratory flight when they fly back and forth over the Himalayan mountains as they migrate through Asia every year. And then in the upper right corner, that little guy is a blackpoll warbler, which again might be familiar to some of you. These little birds, to get from New England down to their wintering grounds in kind of the northern region of South America, they launch themselves out over the Atlantic Ocean and spend 3 days flying nonstop over the open waters of the Western Atlantic, which maybe sounds less impressive than a godwit, flying nonstop for a week to cross the Pacific, but a godwit is like the size of a football, and a blackpoll warbler weighs about the same as a ballpoint pen. So it's actually pretty astonishing. But for me, what fascinates me just as much as what migrating birds do and how they do it is how we figured all of this out. How do we know that this is what these birds are doing? So that is what my book is really about, and that's what I'm here to get into just a little bit tonight. So before I dive into that, I want to give some really quick background on myself and how this book came to be. So before COVID, I worked for the American Ornithological Society, which is kind of a mouthful, but it's the big professional organization for ornithologists, for bird scientists in North America. So they give out research grants, they put on an annual scientific conference, and they also publish two peer-reviewed scientific journals, which are what you see here. So this is where scientists publish their reports on their new findings, the results of their studies. My role with AOS, I was their one-person communications department, so I wore a lot of hats. But a big part of my job was promoting the new research that was promoting and publicizing the new research that was being published in these journals. So getting it out there in the form of press releases and blog posts and what have you. So I was reading a lot of scientific papers. And I don't know how many of you are familiar with the structure of a scientific paper. They all follow the same basic format, right? So there's the introduction, where the researchers explain, what question they were trying to answer and kind of put it in context and make a case for why it's worth studying. There's the methods, where they go step by step through their procedures and how they collected all their data, how they did their study. And then there's the results and the discussion where they talk about what they found and what it means, and again, kind of put it in context and talk about where things might go from here. And so I was reading all of these papers, and I kept finding myself absolutely fascinated by and sucked in by the section that I think a lot of people kind of skim through to get to the good stuff, which is the methods, the how of how they were doing these studies. I didn't know, or if I had learned in my undergrad ornithology class, I had forgotten that you can study bird migration using weather radar. You can study bird migration by putting out microphones to passively record the unique flight calls of birds that are passing overhead. You can study bird migration by analyzing rare hydrogen isotopes in bird feathers, which we're not going to get into that one tonight, but it is wild. And there's a whole chapter in the book going into how they even figured out that that was a thing you could do to learn about migration. And so at some point, while reading all these papers, I started thinking, again, how do we figure all of this out? Who even figured out that you could do these things and kind of made it work? Like, what is the history behind all of these techniques? And so when the pandemic came along, I ended up leaving that job and I decided to turn that idea, that curiosity, into a book proposal. And that became the book that was published 3 years ago now. So this is the table of contents of the book. If we had more time, we could play a guessing game where you have to guess what migration data collecting technique goes with what chapter title. Because basically what I do in the book is I go roughly in chronological order through each of the major methods that's been developed over the last 100+ years to collect data on bird migration and figure out where birds are going. So beginning with the early origins of scientific bird banding and like the opening years of the 20th century, and then going all the way up through things like artificial intelligence tools to analyze huge data sets and high volume genomic sequencing, stuff like that. So this is all in the book, but it is way more than you can, cram into a 45-minute book talk. So years ago now, when I first started inviting to come give talks about the book, I thought about how I would adapt this into a talk that would be fun to give and hopefully fun to listen to. And I decided that what I really wanted to do was just zoom in on three of my favorite stories from the book. So there's a ton of stories in the book, but I was like, I'm going to pick three that I know are entertaining and I'm going to share those. And so that's what I'm going to do. And then I'm going to wrap up by talking a little bit about why all of this matters for bird conservation. And my hope is that you will come away from this with a new appreciation of all the hard work and creativity that went into uncovering every gee whiz fact that you might hear about bird migration. All right, so the first tactic for figuring out what migratory birds are doing that I want to talk about is one that I had not actually heard of before I started doing the research for the book, and this is called moon watching. So I'm sure a lot of you are aware most songbirds migrate at night. This means that if you want to see their behavior, you can't just look up and watch them flying overhead, right? Because not only are they pretty high up, but also it's dark outside. So you need to get creative if you want to observe them and see what they're up to. Excuse me. Now, today we have all sorts of high-tech tools like radar and satellite telemetry to help us spy on these night migrating birds. But before any of that technology was developed, this guy, whose name was George Lowry, came up with a really clever way to do this using just a telescope. So, George Lowry was born in Louisiana in 1913. He was an avid, obsessive birder from a very young age. In 1936, he finished his master's degree from Louisiana State University in Baton Rouge. And except for a brief stint when he went elsewhere to complete a PhD, he stayed on there for the rest of his career as an instructor and an ornithologist, and he helped found LSU's Museum of Zoology, which is still thriving today. Now, growing up along the coast of Louisiana and being, again, a very enthusiastic birder, George Lowry would definitely have been familiar with the phenomenon of migratory fallout. So this, of course, is when birds that are migrating north across the Gulf of Mexico in spring. I've never gotten to witness this personally, but sometimes depending on weather conditions, they just sort of fall out of the sky en masse at the first bit of land that they get to after finally getting across the Gulf. So in the first grove of trees behind the beach, you can get these incredible, incredible concentrations of every sort of migratory songbird just like dripping out of the branches. And although there wasn't really any way to prove it at this point in time, a lot of ornithologists in the early 20th century, George Lowry included, thought that it was likely that migrating birds crossed over the open water of the Gulf of Mexico on a regular basis, that this was a pretty normal part of the annual cycle of these long distance migrants, this flight over the Gulf. But then in the 1940s, another biologist named George Williams, this is our second George, we're going to have three total. It was a popular name for mid-century biologists. I'm sorry. So George number two, George Williams, comes along and says, hang on, wait a minute. This doesn't make any sense. Why would all of those birds voluntarily choose to fly over hundreds of miles of open water when Mexico is right there? Basically, he was like, guys, I know we don't see these birds in Mexico a whole lot during migration, but we're just not looking hard enough because this is the only thing that makes sense. Now, George Lowry, who had seen the admittedly circumstantial evidence of trans-Gulf bird migration with his own eyes in the form of fallout, right, was really annoyed by this and really determined to prove George number two, George Williams, wrong. They had a really testy back and forth in the scientific journals of the day, like rebuttals of rebuttals of rebuttals. It was great. And so Lowry started casting around, trying to think of some method that he might use to prove that large-scale migration across the Gulf was a real phenomenon. And he remembered some quirky ornithology papers that he had read from the very early years of the 20th century, where folks had reported looking at the full moon through a telescope during bird migration season and being able to see the silhouettes of these night migrating birds passing in front of the moon, sometimes in such detail that they could even tell roughly what kind of birds they were looking at. And so Lowry thought, all right, this is interesting. I think I could do something with this. Luckily for Lowry, there was an astronomy professor working at LSU at this time who was also interested in birds. And so Lowry and this astronomer put their heads together, and what they came up with was a set of equations that would let Lowry take a raw count of how many birds he saw passing in front of the moon in a certain amount of time and do a bunch of math and turn this into an estimate of the total number of birds crossing an imaginary 1 mile line on the Earth's surface at that location every hour. Now, this sounds pretty abstract. It is pretty abstract. But what this boils down to is that Lowry now had a way to measure, to quantify the volume of migration happening at a particular place in time, which there had never really been a good way to do before, and to compare it with the amount of migration happening at another place in time. Lowry called this the migration traffic rate. And with this, he thought that he finally had a tool to demonstrate just the volume of birds passing north over the Gulf in spring. So April 1945, George Lowry packs up a telescope and he boards a boat, a ship, I don't really know how big it was, to be honest, heading across the Gulf of Mexico for a port on the Yucatan Peninsula. This first night out in the Gulf, he's so excited. Lowry goes up on deck and he sets up his telescope and he points it out at the moon. This is his big moment. He's going to prove George number two wrong. He looks in the eyepiece. Lowry did not have any experience at sea, and he had failed to anticipate the fact that when he looked at the moon through the telescope on the deck of the ship, the moon would be bobbing up and down, in and out of sight with the motion of the waves, making it impossible to get an accurate bird count. But George Lowry was not a man who gave up easily. He knew there must be thousands of birds streaming overhead. So he waited until they arrived in the Yucatan in port where the water was calmer, and he tried again. He set up his telescope and he pointed it at the moon out over the Gulf. And in 45 minutes, he counted 12 birds. That may not sound like a whole lot, but when he did the math, this worked out to more than 3,700 birds passing over a 1 mile line extending out into the Gulf every hour. So George Lowry had just collected the first hard numerical evidence that large-scale trans-Gulf migration, which I think we now all kind of take for granted, was a real phenomenon. Now, Lowry was just getting started. He felt like he was onto something big here. And his next idea for moon watching was that he was going to scale it up. He was going to recruit volunteers from across North America to collect this type of data.
They're not going in. No.
If we could, if folks could just make sure that you're on mute, unless you need to jump in, that would be really helpful. So he was going to recruit volunteers from all across North America to help collect this kind of data. Today, we would call this citizen science or community science, and there's a whole chapter in my book just about that. But in the 1940s and 50s, those terms hadn't been coined yet. Lowry just knew that he had hit on a method that had the potential to reveal migration patterns at the scale of the entire continent for the first time. But this was going to be an enormous undertaking. He wasn't going to be able to do it alone. And luckily for Lowry, a new character enters the scene right at this time. So Bob Newman arrived at LSU as an enthusiastic young graduate student, and like Lowry, Newman ended up staying on at LSU for the rest of his career studying birds. So this is Lowry again on the left, this is Newman on the right. This is clearly not Bob Newman as an enthusiastic young graduate student, but it turns out that in the pre-smartphone, pre-digital camera era, there weren't a lot of photos published of people until later in their careers when they were famous. So I could not find any photos of young Bob Newman. Please use your imagination to de-age him. So again, like Lowry, Newman ended up staying on at LSU for the rest of his career, and these two men formed a working partnership that lasted all the way until Lowry's death in the 1970s. Bob Newman also passed away decades ago, so I did not get to interview either of these men while working on my book, but I did talk to a really lovely ornithologist named Sidney Gautreaux, who's now in his 80s, who worked with both of them when he was a grad student in Louisiana and has a delightful Louisiana accent, who was kind enough to share his memories of both of these men with me. And it sounds like, in a lot of ways, these two guys could not have been more different. They were sort of the odd couple of ornithology, if you will. Lowry was an old school gentleman naturalist. He would have been right at home in the 19th century. He wore a suit and tie for field work. He organized expeditions into the jungle to gather new specimens for the university museum. He was a workaholic who would go home to eat dinner with his wife, only to reappear in the office in the evening to sneak in a little more work. Newman, on the other hand, was a jokester. He had a reputation for his sense of humor, and he also approached problems much more like a modern scientist. He taught himself statistics before that was a common skill for zoologists. You did not need to know stats to be a zoologist at this point in time. And he also made it a personal mission to keep up with the latest bird migration research being published all over the world. So together, these two men came up with a plan to collect a snapshot of migration activity across the entire continent during a single week in October. I should maybe clarify with moon watching, you can't just do it on the full moon. It works pretty well for a couple days on either side of the full moon also. So you've got a pretty good window each month. Now, no one had ever tried anything before. This was going to be on a huge scale. This was before the internet. It was basically before computers. There might have been a couple, primitive computers in America at this point, but these two guys definitely did not have access to them. So the way they pulled this off was they spent up to 12 hours a day handwriting letters to hundreds of potential volunteers around the country, targeting local birding clubs and local Audubon chapters, explaining their project and its goals and what volunteer data collectors would have to do and the special contribution that participants would be making to science. And they were eventually able to recruit 2,500 volunteers in 325 locations from Canada down to Panama, willing to give this a try. They really wanted to make sure that the data that they got back was as high quality as possible, so they even took the step of printing up a physical how-to pamphlet that they mailed out to all of their volunteers, complete with some tips on how to make yourself comfortable for long stints of staring up at the sky. This is an actual illustration from one of their how-to pamphlets. I saw this and couldn't stop laughing. I mentioned that Bob Newman was known for his sense of humor, so I can't decide if this was supposed to be humorous or if it was just the 50s. I don't know. Finally, in fall 1952, telescopes swung into action across North America. Pretty soon, observations were flooding in. Paper data sheets mailed from every corner of the continent were stacking up higher and higher on Lowry and Newman's desks, and they realized that they had another problem, which they should have given more thought to ahead of time, which is how they were going to analyze all that data. Again, no computers. This was before most zoologists had any training in statistics. They now had to calculate the average direction and volume of bird migration from each of these hundreds of locations. They wanted to look for connections with the weather, so they had to look up data on temperature and wind and the movement of cold fronts for each of those locations in printed bound volumes of weather records, which were a thing at the time. And then they had to depict all of this on easy to interpret maps, which they would have to draw by hand. It took them 14 years to complete and publish their analysis. Finally, in 1966, their magnum opus appeared in the ornithological journal, the Auk, which is one of the same journals that I would be working for about 5 decades later. They titled this A Continent-Wide View of Bird Migration on 4 Nights in October. This paper was filled with page after page of these painstakingly crafted maps where they used these red, black, and white arrows to indicate the direction and volume of migration at different locations across the continent on the nights of October 1st through 4th, 1952. And you really could see these continental scale patterns. You could look at these maps and see these massive migratory flights spanning multiple states in the Midwest and East. You could see how the birds were kind of advancing with the movement of advancing cold fronts, and how these weather patterns affected migration. I feel like today, when we're so used to, satellite images of the Earth from space and things like that, it's almost hard to think about how groundbreaking this must have been at the time if you were someone who was interested in bird migration, because seeing this laid out at this scale, this had never been possible before. So this paper was a blockbuster. It was 40 pages long. It influenced studies of migration for many years to come, but this was also the last moon watching paper that George Lowry and Bob Newman would ever publish together, because all of this hard work was about to be made almost totally obsolete by the rise of a new technology, which was radar. So I'm sure some of you have seen an image kind of like this before. This was taken from the nationwide weather radar system, the same one that you see images from on the Weather Channel, with the green and orange blobs to show you where rainstorms are. There is some rain on this map. It's sort of that big streaky green area over on the East Coast. But those round blobs all down the middle of the continents, those are birds. Now, they generally filter migrating birds and other distractions out of the radar images that they use for TV weather reports, but birds actually show up really well on radar. And so these round blobs that you see here, what each of these actually is, it's just the field of view of one individual radar station. And during peak migration, these waves of birds taking off in the evening for their night of flying across the continent can essentially saturate the field of view of individual radar stations as they take off. And so that's what creates this pattern of round blobs wherever bird migration is heavy. But when people first started using radar in a big organized way, it hadn't really occurred to anyone yet that they might be able to see birds. They weren't looking for birds. They also weren't looking for rainstorms. They were looking for Nazi planes. Here's where we get to talk about World War II. All right, so to get technical very, very, very briefly here, just a little bit, radar actually stands for radio detection and ranging. I did not know that prior to writing this book. I don't know how common, maybe everyone knows but me, but I was not aware that it had a meaning like that. And the way radar the way radar works, there is a special radio transmitter that's beaming out these radio waves. They are bouncing off of whatever objects they run into out in the world. And so some of that energy is being reflected back to the radar equipment. And how much energy comes back and the angle that it comes in at tells you something about the size and distance and movements of any objects that are out there. It's basically like sonar or echolocation, but with radio waves instead of sound. British scientists had worked all of this out by the 1930s, and so when World War II got going, they quickly built a network of radar stations up and down the British coast as an early warning system to detect incoming planes from the European mainland. But pretty much as soon as these new radar stations were operational, they started picking up these weird signals that they didn't know how to explain. So planes, as seen by these early radar stations, the blips sort of plotted along at a consistent speed and trajectory, but they were seeing these weird little things that appeared and disappeared and zipped around and changed direction. They had no idea what they could be looking at. Supposedly, at one point, a red alert was sounded and British fighter planes were urgently ordered into the sky to intercept strange signals heading across the English Channel, only to get up there and find nothing there. And so the exasperated radar operators started calling these things radar angels. You can all see where this is going, I hope. All right, so while all of this was going on, this fellow, whose name was David Lack, had been teaching science at a secondary school in Devonshire in southwestern England. And he did not know it yet, but he was about to become the father of radar ornithology. And once again, David Lack was a young man at the period of time that we're talking about. There's no photos out there of young David Lack. So Lack had always been interested in birds. He had actually studied ornithology at Cambridge before accepting this teaching job. In 1938, he took a year off from the school to travel to the Galapagos Islands to study Darwin's finches there. He got back to the UK just as the war was getting going. Lack later wrote a partial memoir, like a short memoir about the early years of his career. And so I'm going to read to you a quote in David Lack's own words about his experience when he arrived back in England. I had become a pacifist at the age of 17, so he signed a pledge to an anti-war organization. And in the autumn of 1940, I decided that I ought to leave my job at the school to work with a pacifist unit. I spent a trial night in the East End of London during heavy raids, but was so put off by the pacifists' earnest attitudes and so excited by the flashes and bangs that I was immediately converted from pacifism. A month later, the Central Register for Scientific Workers sent me to interview for an unspecified job. So he's going to join the war effort, but because he has a science background, they want to give him a science job in the war effort. As a biologist, you will of course have learned a lot of physics, the interviewer said. I'm afraid not, I answered. Well, I expect your maths is of a high standard. I'm afraid not. Then very doubtfully, I fear this job will often entail going out in the wet and cold in the dark. Would you mind that? Not at all. So I was taken on, and 10 days later set off from London with 19 other biologists on a mystery coach tour. He ended up somehow working on radar stations. By the way, it's always fun to discover that the historical person you're writing about actually had a great sense of humor. David Lack was a hilarious guy. So Lack, once he fell into this line of work, he was first posted to the Orkneys, which are a wet, windy, remote group of islands off the north end of Scotland. He was probably the only person happy to get that posting because the birding was really good. He got to spend all of his off hours scrambling over the rocks looking for puffins and stuff. Shortly after that, though, on a tour of radar installations up and down the coast, he was reintroduced to an old acquaintance of his named George Varley. I promised you three biologists named George. This is the third and final one. So Varley, George number three, had been a classmate of Lack's from Cambridge. He had been an entomologist before the war, so he was a bug guy, but now he'd fallen into the same line of work as Lack, and it was Varley who introduced Lack to the mystery of the angels plaguing the radar operators. Now, Lack was an ornithologist by training. He was familiar with the behavior of birds in flight and by now familiar with how radar worked. He heard the description of these strange signals and he pretty much immediately was like, oh, guys, it's birds. It's birds. No one believed him. They all thought that that was impossible. So Lack and Varley decided that they were going to put their heads together and prove that this is what was going on. So convinced all these skeptics. They got pretty creative about it. At one point, they convinced an officer to tie a dead gull to a balloon and send it up into the air in front of a radar station just to prove that it was possible for a bird body to produce a radar signal. Finally, in September 1941, they managed to use a powerful telescope to confirm that the source of a signal being tracked offshore in real time was in fact a flock of gannets. They could see the blip on the radar screen and they could see the gannets at the same time through the telescope and could show that this is exactly what was happening. As the war continued, Lack and Varley continued to collect radar observations that they believed represented birds. The technology was advancing quickly, so they could soon pick up things like flocks of starlings and whatnot this way. And they continued to gather data that confirmed that the characteristics of the so-called angels were consistent with the behavior of birds in flight. Not everyone was easily convinced, and so I have one more short David Lack quote about the skeptics. At one meeting, he wrote, after the physicists had again gravely explained that clouds of ions must be responsible, Varley with equal gravity accepted their view, providing that the ions were wrapped in feathers. He was snarky, this man. They stuck with it, and in 1945, as the end of the war neared, they finally got permission to publish their previously top secret findings in the journal Nature. Today, Lack, who died in 1973, is better remembered for a book that he wrote about Darwin's finches, but this short publication essentially kicked off the entire subdiscipline that we now know as radar ornithology. Radar ornithology might have been sort of a footnote in my book instead of an entire chapter, if not for the fact that after the war, meteorologists jumped on this technology, and starting with some surplus army radars, they started developing radar as a way to provide early warnings about hurricanes and other major storms. Flocks of birds show up just as well on weather radar as they had on military radar, so building a nationwide weather radar network was great news for ornithologists interested in these large-scale migration patterns. And over time, as this technology has advanced, it's just made it possible to gather better and better information about bird migratory patterns. And this is still an important data source for this to this day. Usually when scientists are looking at birds on weather radar, that you don't know what individual species you're looking at. You're not seeing individual birds. You're just seeing those sort of big clouds like we saw with the blobs in the beginning. But it's still very useful for kind of looking at those large scale patterns of when and where there's a lot of migration happening and where there's not. So this is just to give you one brief example of what you can do with this kind of data. This is a figure from a paper that was published in 2018. For this, two scientists who were affiliated with the Cornell Lab of Ornithology downloaded radar scans covering all of the continental US for every evening for 23 years, more than 150,000 individual radar images. They did an analysis to see how weather factors like temperature, wind, air pressure predicted the appearance of big migration movements on radar. Because even though, migration is a season that goes on for weeks, there's not an equal number of birds in the sky every night, right? There's big nights and there's quiet nights. So they were looking at like what weather factors kind of determine when it's going to be a big night. And if you've been paying attention, yes, this is basically the same thing that Lowry and Newman were trying to do with their moon watching data, but now we have these giant data sets and computers to help us analyze them. And so when they did this, they found that their math explained almost 80% of the variation in migration intensity from one night to the next, and that using this method, they could even predict big migratory movements several days in advance. So if you are familiar with Birdcast, which is this amazing forecasting tool put out by the Cornell Lab of Ornithology, where you can log on during migration and get a forecast for about how many birds are going to be passing over your area tonight. This is the technology that Birdcast is based on. And it is all thanks to a witty science teacher from Devonshire who realized what must really be going on with those so-called angels annoying the radar operators guarding England from the Nazis. Excuse me, one sec. All right. Of course, radar is not the only way to put radio waves to work tracking birds. And this brings me to my third, final, and favorite migration innovator for the evening. Okay, this guy's name is Bill Cochran. It's young Bill Cochran on the left. I actually have a photo of young Bill Cochran. Bill Cochran later in his career on the right. In the mid-1950s, Bill Cochran was a young Navy veteran working on an electrical engineering degree part-time while also working for a brand new television station based in his hometown of Champaign, Illinois. One morning, he headed out to check on his employer's transmitter tower on the outskirts of town, and there he found this guy picking up dead birds from the ground. Cochran was very curious about this. He wanted to know why this man was here and why he was so interested in these dead birds. Turned out the guy was an ornithologist from the University of Illinois. His name was Richard Graber, and he was studying tower kills, which is this phenomenon where flocks of birds fly into communications towers and are killed by the impact. Cochran, again, was intrigued and struck up a conversation with this man, and they kind of hit it off. And pretty soon, Bill Cochran, who again was an electrical engineering student, was spending his spare time kind of tinkering together gadgets that could help Graber in his bird research. Bill Cochran appears in more chapters of my book than any other single researcher. The first project that he and Graber worked on together was figuring out a way to record the nocturnal flight calls of birds flying overhead. So these night migrating songbirds, some of them make unique calls while they're flying at night that they don't make at other times. And if you know these calls, you can use them to identify the species that are passing overhead. And Cochran and Graber were the first people to actually make recordings of these calls. And so one of my favorite little stories from the whole book is Cochran, who again was an aspiring engineer, figuring out how to rig up a tape recorder with bicycle axles to hold the 6,000 feet of tape that they would need to record an entire, 8-hour night of birds passing overhead. But the chapter in my book where Bill Cochran looms the largest by far is the one on radio telemetry. So telemetry just means transmitting data from place to place in real time. And there were two technological advances right around this time that really helped kick off the field of radio telemetry. The first one was the invention of the transistor in 1947. So this is a photo of a replica of the first transistor. To boil this down to just the essentials, we don't have to get into how transistors work, but before this, radios relied on vacuum tubes to amplify the signals that they were sending out, which were bulky, breakable, not that reliable. When transistors came along, these provided a lightweight, efficient, durable way of doing the same thing. And this made it possible to adapt radios to all sorts of sensitive tasks that they wouldn't have been suited for before, including transmitting sensitive data from one place to another. One of the first groups to actually jump on this and start experimenting with it was the US Navy. So they worked very quickly trying things like using radio signals to transmit real-time data on a jet pilot's vital signs to a doctor monitoring them from the ground as they were doing test flights, and to monitor the effectiveness of cold water suits for sailors by transmitting out temperature data from inside the suits in real time. But it did not take long for wildlife researchers to begin borrowing these same techniques. Really, my whole book is just a history of ornithologists being really, really good at stealing advances from other scientific fields. So in 1957, some scientists in Antarctica used the system from the cold water suit tests to remotely monitor the temperature of a penguin egg during incubation. That's what's going on here. Those are penguins being manhandled in the lower right-hand corner of this photo. That same year, a group of researchers in Maryland borrowed some ideas from the Jet Pilot project and surgically implanted transmitters in the body cavities of woodchucks to monitor their movements around a little nature preserve. Pretty soon, big engineering firms were getting involved with this, trying to design radio tracking systems that they could market and sell to wildlife biologists to use to track animals' movements. But they were trying things like strapping a metal box containing a radio transmitter to the back of a grouse and releasing it into the bushes. And it's tricky to make this actually work in the field, right? A grouse with a big metal box strapped to its back is not going to last long in the wild. So before wildlife telemetry could really take off, someone was literally going to have to think outside the box, haha, and that someone turned out to be Bill Cochran. Now, I did say there were two technological advances that played into this story. I talked about one, that was the transistor. The second thing that enters into this is the launch of Sputnik in 1957. So this, of course, was the first artificial satellite. It was launched by the Soviets. Basically, all it did was circle the Earth and beep. But if you had a radio receiver and you knew what you were doing, you could pick up this beep from space from anywhere on planet Earth. And this touched off a whole new wave of fascination with radios and what you could do with them. So by 1960, Bill Cochran, who had still not quite finished that electrical engineering degree, but was apparently really good with transistors, had picked up more part-time work helping a University of Illinois radio astronomer build some radio beacons that were going to be launched on some of the first US satellites being sent up in response to Sputnik. These were actually spy satellites, although Cochran and the astronomer did not know that that's what they were working on. Cochran was also still doing some work with Graeber and his colleagues over at the Illinois Natural History Survey. And it did not take long before someone suggested they try combining Bill's two gigs. Like, hey, Bill, what would happen if we took one of your radio gizmos that you're building and we put one on a duck? I don't know, sounds fun. Let's try it. So they sent a duck from the field station on the Illinois River over to the satellite lab. They strapped a radio transmitter onto this bird using a metal band that went around its chest. And although they hadn't really planned this, it turned out that the bird's breathing distorted the metal band in a way that affected the radio signal, so that when they released the duck into the air, they realized that they could track its respiratory rate as it flew, accidentally collecting some of the first data on the vital signs and the physiology of a bird in flight. And so they all got a nice scientific publication out of this about, tracking the vital rates of a bird in flight. And that moment when a duck took flight wearing a radio transmitter that he had designed, we'll never know what was going through his head, but it seems like something clicked for Bill Cochran. And in that moment, he found his calling, he found his thing that he was going to do for the rest of his life. He was going to build radio transmitters for birds and for other wildlife. And I should be really clear here, even though we're mostly focusing on birds and Cochran did a lot of work on birds, really all wildlife radio telemetry goes back to the work that he did. He was the first person to make this possible. So all the radio collars for wolves and deer and stuff, that all goes back to Bill also. Now, Building a radio transmitter to be worn by an animal requires making trade-offs among a long list of factors. A longer antenna will give you a stronger signal, and a bigger battery will give you a longer lasting device, but they both add weight. And Cochrane, who wouldn't officially finish that electrical engineering degree for several more years, turned out to be really good at getting this balance just right. He favored designs that were as small and simple and compact as possible. And instead of putting the components in a metal box, he figured out how to dip the whole assembly in plastic resin to seal and waterproof everything together. Now, one of Cochrane's first gigs was working with a biologist who was surveying the local cottontail rabbit population, but as soon as word got out, biologists were clamoring for his services. He was figuring out how to build smaller and smaller and smaller devices all the time. And within a few years, he had figured out how to build transmitters small enough that they could safely be placed on songbirds as long as they weren't below a certain minimum weight threshold. Like, we're not talking tiny warblers here, but decent sized songbirds. This was great news for his old friend and mentor, ornithologist Richard Graeber, because Richard Graeber was studying thrushes and he was interested in learning more about their migratory behavior. But these devices, these transmitters, they only had a range of a few miles, right? So if you wanted to use one to follow a migrating bird, you literally had to follow this migrating bird. So 1965, Graeber, the ornithologist, finds a pilot who is willing to try following a migrating radio-tagged thrush at night in a small plane. This is the plane they used on the left. They called it the porcupine because of all the antennas. May 1965, they capture a gray-cheeked thrush outside Urbana, Illinois. They trim a little patch of feathers on its back to get to the bare skin, and they stick on a tiny radio transmitter using eyelash glue, the same stuff that women would use to attach false eyelashes, which is great for this because it's non-toxic and it doesn't irritate the skin and it wears off on its own after a while. And so that evening, they waited, until the sun was setting and the bird, was foraging nearby and eventually took off for its night of flying, and they were able to pick up the signal. And Graeber and the pilot followed this bird north for 400 miles before turning back, 200 of which were over the open water of Lake Michigan. They couldn't see the bird, of course. They were just flying through the night, listening to this sort of wavering beep, beep, beep over the radio in the little cockpit. But Graeber, the ornithologist, was so awed by this experience and by the new appreciation that it gave him for what these little birds were really doing, that when he later wrote about this night for Audubon magazine, he compared it to how he felt watching the television coverage of the Apollo moon missions. And Bill Cochrane was just getting started. I've just got a couple more slides, I promise. 1973, Cochrane and a student named Charles Welling tagged another thrush passing north through Illinois in the spring, and this time they spent a full week following this bird almost 1,000 miles all the way across the Canadian border and up into Manitoba in a station wagon with a hole cut in the top for their radio receiver. You can see the photo of it here. This was their vehicle. They later wrote this experience up in a very dry 2-page scientific paper. And when I was doing the research for this book, I read this paper and my jaw just dropped. Like, they did what exactly? And of course, there were all sorts of incidents along the way that did not make it into the scientific paper. At one point, the student who was along to help drive apparently basically spent a night in jail because a suspicious police officer pulled them over in rural Minnesota. And I can't really blame him. Who would not be suspicious seeing this thing passing through your small town in the middle of nowhere, in the middle of the night, during the Cold War? So Cochrane didn't want to stop for too long. He was worried that if they lost the bird's signal, they would never pick it up again. So he basically kicked the kid out of the car to try to sort things out with the cop, kept on driving until the bird set down in the morning where he knew he'd be able to find it again in the same area that evening, doubled back, bailed him out, and on they went. The only reason they stopped after they crossed into Canada was that the car's engine finally gave out. Every night they were gathering data on this bird's altitude, its airspeed and ground speed, the distance that it covered, its heading. And because they were able to stick with this bird over such a long distance, this one individual bird, they were actually able to track how the precise direction that the bird set out in each night changed slightly as its position changed relative to magnetic north. So this was some of the first real world evidence that songbirds were using some sort of internal magnetic compass as one of their navigation tools for these long distance migrations. All right, Bill Cochran never really got the hang of the politics of academia. He was always kind of an outsider. He was an engineer in a world of biologists. He never fully understood the peer review system for scientific publishing. Some of what he did, he published in scientific journals. Some of it he published in the magazine of the American Falconry Hobby Association. So he didn't really know how to get the word out there about what he was doing. And so he always remained a little bit of an outsider. He was also, I think, just kind of a crotchety guy on a personal level, maybe not the easiest person to get along with. And by the late 1990s, he had left his job with the Illinois Natural History Survey on what I gather were maybe not the greatest terms. He burned some bridges on his way out. But he kept building radio systems for ornithologists in his garage right into the beginning of this century, and he would invite people to come stay in his guest room and learn to do this with him. I had the great good fortune to actually speak to Bill Cochran multiple times while I was researching my book, and even to visit him at his home in Illinois, where this station wagon, now minus the antenna, was still parked in the driveway. And most of his backyard was taken up with an enormous radio receiver tower. He was a hilarious character. Among other things, he liked to screen his calls by pretending to be a janitor at an animal shelter when he answered the phone. So I would call him at a prearranged time for a phone interview, and he would pick up the phone and go, "Animal shelter, we're closed." I'd be like, "Bill, is that you? It's Rebecca." It was quite something. Sadly, Bill passed away in 2022 at the age of 90 before the book came out. I really believe that he is an unsung hero of 20th century science, and I'm happy that my book is hopefully making a few more people aware of all the things that he accomplished. All right, I've been going on and on. It's been longer than 45 minutes. I'm sorry, but I'm really almost done. So in my last couple minutes, I want to talk about the concept of migratory connectivity and why this matters for conservation. I did want to mention I chose historical stories for this talk on purpose because I have a few times given this talk to audiences of ornithologists, and I didn't want to find myself talking about someone who was in the audience, so it seemed safer to pick the stories that came from the past. And where I'm going with this is that if you get a chance to read the book, I promise that the book is not all dead white guys. There's a lot of, I'm sorry to be blunt, but there's a lot of, women and cool people from Asia and South America who are involved in this research now, who are involved in this field. And so I talked to all those folks in the book. And, I'm not just covering history, I also cover the more recent developments in this field, like the latest tiny miniaturized satellite tracking devices and AI tools for analyzing big data sets and high volume genetic sequencing, all that stuff. Thanks to all of these recent high-tech advances, we now have a clearer, more detailed picture of bird migration than we've ever had before. This data can help us target conservation efforts more effectively. And that is something we really need because migratory birds are not necessarily doing that great. You might have heard about this paper when it was published. It was back in 2019, so it's been a while now, but it made a big media splash when it came out. This is what was called the 3 billion birds paper, because a large group of ornithologists drew from a bunch of different data sources to come up with this estimate that there are 2.9 billion with a B fewer total breeding birds in North America now than there were in 1970, which is just a staggering loss. Researchers and wildlife managers, since this paper came out, have been scrambling to try to figure out, how to stop the bleeding. And when it came time to write a conclusion for my book and try to tie a bow on this whole thing, I wanted to talk about whether some of these new tracking technologies are part of the answer, and also just whether there's any reason to feel hopeful when we're confronted with these sort of numbers. So what I did was I called up two of the leading experts on migratory bird conservation in North America. I talked to Pete Mara, who's one of the senior authors on this paper. He was formerly the head of the Smithsonian Migratory Bird Center. He's now at Georgetown University. And I also talked to Jill Debbie, who's the head of the Audubon Society's Migratory Bird Initiative. And so I called them both up and I asked them questions like, what is the state of migratory bird conservation today? And are you hopeful about the future? And they both had strikingly similar things to say. They agreed that despite all of the ever more detailed migration research that is happening now, we still need more data to understand what's behind the declines in many of these species. They agreed that there is a need to consolidate the data that is being collected, get it into the hands of policymakers and conservation activists, to get better at working across international borders, to incorporate more partners in the social sciences, more perspectives from Indigenous people. And somewhat to my surprise, they both insisted that yes, there is still a reason for hope. And so I'm going to close by reading a brief quote from what Pete Mara said to me when I asked him if he feels hopeful about the future. He said, I'm very optimistic. We've done this in the past, we've corrected other environmental issues, and now we have to deal with climate change. So while it seems like there's this overwhelming deluge of negative issues and challenges with getting people on board with these things and constant pressures on nature, I just choose to be optimistic and hopeful just because I don't see any benefit of being pessimistic or having a lack of hope. I just don't choose to take that route. Don't get me wrong, there are times when I might be negative or spiraling down into a pit of agony, but I'm not going to do that. I thought those were wise words. I don't know about all of you, but when I find myself spiraling down into a pit of agony, I usually just go birding. So that's what I've got for you. I'm happy to take questions. Thank you so much for having me. Really quick, I just wanted to say the number one question I always get asked is, are you working on a second book? I am not currently working on a second book. I have no announcements in that regard, but I do a lot of other freelance writing. So I do a lot of like magazine type writing for the Cornell Lab of Ornithology magazine and other places. So if you go to my website, which is right here, and I can put it in the chat too, RebeccaHeisman.com, I have a little monthly email newsletter you can sign up for. The next one will actually go out tomorrow where I share, links to things that I've written recently and other interesting bird news and book recommendations, that sort of thing. And of course, you can also on my website find links to order the book, or I would also love it if you're interested if you would order it through your local independent bookstore. That is a great way to do it also. I'm sorry that I'm not there to sign copies in person. And yeah, if there's time, I would be happy to take some questions. Let's see. I'll stop my sharing too.
Okay, Rebecca, thank you so much. That was terrific. And thank you for all the Georges and the moonscape description. I can't I have a scope. So in the summer we go where it's very dark, and I can't wait to just shine. Put my well, it won't be migration, so I won't get to see it. That's right. So lost cause. Anyway, so we have some questions in the chat. Let me start coming through some of them. So Tina Morgenstein, realized you were talking about George Lowry at LSU.
Yes.
This is astonishing in 1945. What I wonder about is how AI would capture the bird count today. And then I also wonder about how the number has changed since then. So kind of a two-part question.
So yeah, I'm scrolling back too so that I can read these. I'm not totally sure what you mean by how AI would capture the bird count today. If Tina wants to chime in and clarify that, she can. I will say, even though I said that moon watching has pretty much been made obsolete, there are people trying to revive it using video cameras and using machine learning to count the birds so that it doesn't have to be done manually. I do want to say that the sort of artificial intelligence I talk about in the book, the machine learning tools that are used for a lot of this data analysis, are not the same thing as the generative large language model AIs that are sort of controversial now. So this is a different type of thing. but there are, these sort of machine learning tools that can be used for things like counting birds passing across the moon or for pulling out and identifying like nocturnal flight call recordings. And then as far as how the number has changed since then, I mean, it would be interesting, wouldn't it, to repeat the counts that they did as closely as possible and see how those numbers have changed. But I'm certain they've gone down in light of the 3 billion birds decline. So,
Yeah.
Yeah,
Well,
I kind of figured out how to unmute myself
oh yeah,
and sorry. So what I was thinking about really was how much more information is available to us today to really know what's going around around the entire world to be able to get a more accurate sense of how many birds are flying and moving in different directions and how that has changed over time. It's something we don't have control over, obviously,
yeah.
because we didn't have the technology then that we have now, but it would be really interesting to see how things have changed. And of course, from that to investigate the impact of what's caused that.
Yeah, it would. And today, like I talked about, sort of the equivalent technology is weather radar. So in areas where there are good weather radar networks, they can see that traffic. And even though they can't see the individual birds, they can combine radar data with some other types of data to get estimates of how many birds are there and things like that. So yeah, I hope I at least sort of answered your question.
Yes, thank you.
Yeah.
so thank you. Thank you for clarifying, Tina. Kathy Almbach says, thank you for your research and dedication to putting all of this information into a book. Fascinating. And Sheila McCormick says the talk is fascinating, great speaker. Of course, she's talking about you and not me. Uh, the history, Tina again says later, the history is an amazing reflection on Avery life. Couldn't agree more. Alyssa Creamer Parrott says this topic is so interesting, combining human curiosity, history, and birding, which is, by the way, why I love the book and why she says I'm loving this.
Yeah, the book isn't, yeah, just so everyone knows what to expect. If you read the book, it's not really about birds, it's about people who study birds. So, yeah. Like,
but it gives us insight
yeah.
into migration, which I know so many of us are interested in. It's a fascinating subject, and we've had other speakers who have spoken on migration in the past. Steve Saunders says, I loved her book and how she made the science of bird migration so accessible. Could you say a little more about the Terra project today and how we as community scientists can contribute to migration science with these units in our own backyards? Great presentation. Thank you, by the way.
So I had to think for a second about what the Terra Project was, is because you have to remember I was doing the research for this book 5 years ago now, something like that. So that was that backyard device that was going to record and pick up all the wildlife in your backyard. I have to admit, last time I checked, it had not actually launched. I haven't looked in a while. I'll have to check on that and see if they ever actually came out with that product that was supposed to be in development when I was doing the research. But as far as community science, more generally, community science absolutely makes a huge contribution to migration research. There is a whole chapter in the book on community or citizen science where I talk about kind of the history of eBird and all of the really, really cool studies that eBird data has contributed to. So every time you submit a complete eBird checklist, you are contributing to real research.
Thank you. And I know we've had Mike Webster who leads the Macaulay Sound Lab. And
Yes, he's great.
yeah, he was great. He was a great speaker too. And Linda Macaulay was here, who's one of the pioneers using sound recordings. And we've even had Vanya Rower, who leads their specimen lab. And
Oh, yeah.
he gave us a live tour for
Oh
us.
my gosh, I've
Yeah.
interviewed him. He's really cool.
It was amazing. Anyway, back to the question. Lisa Carroll says this is fascinating and entertaining topic and speaker. Tina Morgenstein says so sweet about Bill. Couldn't agree more about that. Alyssa Creamer Parrott says, well done, Rebecca. I enjoyed the human side of your narrative tonight. Kendra Rye, I think RH says, where do you see the new AI merging with your research in the future?
Yeah, I'm never quite sure how to answer these questions about AI. First, I should say, she said with your research, I'm not personally a scientist. I'm a science writer, so I'm not the one doing this research. I'm just interviewing the folks who are and writing about it. If by The new AI, you mean the sort of chat GPT, generative large language model AI that everyone is usually what people are referring to when they say when they say AI now. I feel like I have yet to see a, compelling use for that in ornithology research. I think research is still best carried out by humans, but if there's an aspect of that question that I'm not understanding, Kendra can certainly chime in and clarify. Yeah, I don't really know how to address that because the machine learning and that I talk about in the book, and the book was written before ChatGPT, but the machine learning that I talk about in the book is sort of a different type of AI.
Okay, thank you.
Yeah.
Maxine Schreiber called you fabulous. This was one of the best presentations
Oh,
ever.
thank you.
And we've been doing these Zoom presentations, by the way, since the beginning of COVID. So this is our 6th year on Zoom doing these presentations. So that says a lot. Gay Hers says very interesting and articulate speaker. Thank you. Alyssa Kramer Paris says, do you work with the Dark Skies organization to have people and businesses minimize their lighting, which can help wildlife such as migrating birds, sea turtles, etc.?
Yeah, so I personally know, again, I'm not a researcher, I'm a writer, but I do talk in the radar chapter in the book about the sort of the Lights Out program, which Audubon oversees and is expanded to a number of cities now. And so that's using, sort of the birdcast radar technology to predict when there's going to be these nights of unusually high migration intensity and turn out city lights on those nights to benefit the night migrating birds. Because I didn't really get into it in this talk, but birds are attracted to artificial light at night and it can cause them to become disoriented. So I do get into that in the book. Yes.
Great. And then we're currently working with FAU to help them institute a Lights Out program. Shelley Rosenberg says absolutely fabulous presentation. I don't want it to end. Thank you, Rebecca, for all your wonderful research and enthusiasm. Deborah Kerr says wonderful presentation. Thank you. Kay Gates, thank you. Celia Weinberg, this talk is interesting and awe-inspiring. Sherry Borden, thank you for this great presentation. Fascinating look at history. Chuck Weber says, thank you, fantastic presentation. He, by the way, is our Christmas bird count lead. Monica Weller says, thank you so much for this book and your very entertaining presentation. You picked great stories to share. Kendra Rye says, habitat loss. I wonder if she's referring to something she said earlier. Not sure. Alina Roman says, I'm buying your book as we speak. I am new to birding, and I was wondering if there are other birding related books that you recommend.
Oh, gosh, there's so many. That's so hard. I'm looking over at my bookshelf. There's so many. It's hard to even know what to say. A fun companion for mine might be Scott Wiedensel's A World on the Wing because he talks to some of the same folks that I did, but with a very different focus, like more of a conservation focus than a science and technology focus. So it might be a fun one to read with mine.
Yeah, and he was a previous speaker of ours as well.
He's a lovely man.
I couldn't agree more. Kathy Ombach, bravo for AE for bringing such high quality speakers topics to our meetings. Thank you, and that's why we bring you these incredible people because we like them too. Audubon Everglades, thank you, Scott Circus, Sabina Begg, and Autumn Coyote. For doing an incredible job finding and scheduling these amazing presenters. Kendra Rye, I really enjoyed the presentation. Thank you to all who put this together. Thank you, Audubon Everglades. We have a great virtually their team, Mark Slifkin, Autumn Coyote, Scott Me, Sabina Begg, and Mary Young. And we're the ones who work pretty hard behind the scenes getting these presentations together. So it's very interesting to see what goes on, sometimes free presentations, and sometimes even post. Carrie Freeman says, I love the stories you picked. Thank you for writing about the research that will help us protect birds. Mary Young, Rebecca Heisman's book, Flight Path, How a Passionate Birder and Quirky Bird. So she gives you the web link so that you can buy it directly from HarperCollins. And that is it. Those are some great questions. Thank you. And compliments were just, extravagant. They were great and well deserved, Rebecca. So thank you. And anyway, so thank you, Rebecca, and thank you for joining us this evening. So It takes a great team to help bring you these virtual presentations, so thank you to all of them. And we can't wait to see you on September 1st, 2026, when we kick off our 2026-27 Virtually There Speaker Series, and we will welcome James H. McCommons, author of The Feather Wars, and the Great Crusade to Save America's Birds, for a fascinating journey through the early conservation movement in America. Good night. Thank you for joining us this evening, and enjoy your summer adventures. See you in September. Bye, everybody.
Thank you, everyone.